So today we've got Kraz, the brains of the operation, and he's going to show you how to test and troubleshoot and repair an Atari ST. Check it out. So today Kraz is going to show you his new Atari 1040 ST. It does work, it boots, but it does not boot consistently. So he's going to attempt to troubleshoot and test and come up with why that's happening and do a fix for that. There's also problems with the floppy drive, but we don't get to fixing that one in this particular video, but it is mentioned. But maybe that'll be a subject for another video down the line. But for now, going to focus on this one and particularly the power supply, and there's some inconsistent power issues that are suspected as the culprit to this particular problem. So with that out of the way, I'll let Kraz take it away.
So we're going to try to recap this Atari ST. But before we do that, we're gonna do a bit of scientific proving that there needs to be a recapping done. So this ST is flaky. It does not always boot. However, right now it's in a good mood and it does boot. So I've already taken off the cover and it's hooked up over here to the monitor. So if we turn this on, this will actually behave properly. However, this floppy drive here does not work. All it does is attempt to read the boot sector, but does not boot. I have confirmed that this will work with a GoTech just fine, but it does not work with the standard floppy drive. So overall, a working computer, non-working floppy drive, a noisy video output, although it's not really showing here. Sometimes we'll see lines in general noise. So not a very healthy computer, but overall something that is usable. So we'll turn this off now. All right, we're back. So just for kicks, I have hooked up the GoTech to this Atari ST 1040. You can't see it here because I removed the case, but it is a 1040. And we're just gonna demonstrate that it is working here. And I'm not sure what the floppy is set to boot right now. We've got some classic sinusoidal text, unreadable multicolor demo intro here, with some bleeps and blops. Very cool. We can select the boot manager for the GoTech and reset here, and we'll see that it is absolutely no problem. We are booting, but again, this is a somewhat flaky Atari ST. It is a good time right now. It's in a good mood. It's booting, no problem. However, from time to time, it'll simply refuse to boot and show essentially garbled graphics on the monitor. So this Atari ST is probably a good candidate for recapping. However, before I blindly recap this, I would like to evaluate just how bad, in particular, the power supply is. We're going to take a look at the 5-volt line and the 12-volt line and to see just how noisy they are, because I am in fact seeing noise on the screen here. This is not capturing it well, but there is noise on the video. That should not be. And I am working with the original cable here. Whoops. It's shielded. There should not be any noise here. It's a very short cable as well. So let's evaluate what we're going to do here. Is we're going to use an oscilloscope to take a look at the 5 and the 12 volt line, and we're going to see just how bad these lines are. So let's turn it off first, safety first, and hook it up the probes to the individual 5 and 12 volt lines. Try to move the keyboard out of the way here. We'll find ourselves a ground. Probably this will be a good ground. And then we're going to look at the 5 volts. So generally when you do power supply testing, it is a good idea to test those loaded. And people will tell you, oh yeah, I gotta put a resistor or a cross or something, and that's fine if you're testing the power supply outside of the computer. But in this case, this computer is essentially working, it's just flaking. So we will be testing this in the computer, connected to the computer, and that would be our load. This is what we're gonna, so first we're gonna do the 5 volt line. We're not gonna look at the second channel, only gonna look at the first channel. I forgot if, let's see. Right, we got 10x probe, we got 200 millivolt range, so maybe we wanna go to 5 volt range. We'll do 1. Okay, let's see what happens here. Okay, we've got power. What do we got here? 1 volt per division. Okay, so we are showing 5 volts. It's hard to say, but this definitely looks noisy here. However, at this scale, it's difficult to see. So let's see if we can get a little. Right, so this looks noisy. Here I have turned on the statistics, and it's showing me 440 millivolt peak to peak, meaning that the noise here is about half a volt between the top and the bottom, meaning that you can't quite see it because it's very fast, but the power supply does not output 5 volts. It outputs between 4.5 and 5.5 or 5 volts, and it oscillates very rapidly. So it is noisy on a 5 volt line. As far as this is an older device, you know, it's not exactly yeah, so this is this is the noise we're seeing here on the 5 volt line. So there we go. We got, so now that we're actually zoomed in, we are seeing 360 millivolts peak to peak of noise. Generally, this will probably be fine for something like this Atari ST, but it may cause issues. We really want to see as little as possible here. Hopefully less than 200 millivolts would be, you know, okay. So we're above that. We're 360, 400 millivolts here. This is terrible. So let's take a look at the 12 volt line now, and this might actually be what's causing the noise in this computer. So let's turn it off, safety first, and we'll hook up the 12 volt lines, and maybe we can see some comparisons with the 5 volt line. There we go. It's labeled here 12 volts. Let's see if I can hook it. All right, I'm hooked up. Make sure that there's no short anywhere. Again, we're loading this power supply. Do not test the power supply with no load. This will not be a good test. You want this power supply to be in running condition with a load on it to just see how bad the filtering is. And so far, we've seen that the 5-volt rail is really, really bad. I mean, if I hooked up a modern power supply, you would see, you know, less than 50 millivolts of noise, and we're at like 5 times that. Okay, so let's turn on. Oh boy, oh boy, this is woo-hoo-hoo. Well, this is probably because I'm zoomed in all the way, isn't it? Yeah, 200 millivolt. Yeah, okay, so I'm actually, yeah, okay. So that's noisy too. The peak to peak here is at 200 and, okay, almost 280, 200. I see it sometimes blink at 300 millivolts. So we're, I mean, overall, this is less than 10% oscillation between peak to peak. But it's terrible. I mean, it's noisy. And again, this is why this computer can boot most of the time. But we are seeing noisy outputs on the video, and we are seeing erratic behavior. Sometimes this will just refuse to boot. And that might be because this power supply is actually quite noisy. So we'll try to improve the situation by changing the capacitors. And this would be a justified sort of shotgun approach here to replacing all the caps. So I purchased these from Console 5's capacitor kits. I like Console 5 capacitor kits. They tend to do a good job. You can absolutely find cheaper caps. You can do your own cap kits for a lot cheaper. Anybody can buy capacitors from Mauser or anywhere else really. What I like about Console 5 is that they actually match the size of the capacitor so that they will fit on the PCB, and that is a pain in the neck to do correctly, especially for caps that have different connectors at the end. Here you see these guys are thicker. You really want to make sure that you buy the correct cap for your application, not just the specs as far as capacitance and maximum voltage, but oftentimes the spacing of the leads. Sometimes there's clearance that needs to happen. I mean, anybody can buy, what is this, 220 microfarads, 200 volt capacitor. There's literally hundreds of these available on Mauser. And you'll have these really thick round ones, you'll have these super tall ones, you know, it just, this needs to be about this volume here because you don't have a whole lot of clearance inside of these 1990s, 1980s 16-bit computers. They're just, you know, so Console 5's done the work for you. You don't have to kill your inner child looking for across 50 different capacitors and different brands, and they tend to buy the good stuff. So this is Nichicon. I'm seeing some Panasonics here. Yeah, that's a Panasonic right here, the gold one. This M here means Matsushita. This is 105 degrees, Nichicon. It's probably low ESR. I mean, the guy knows what he's doing. And the difference on this kit is probably like $3. If I had, you know, this is probably like an $8 capacitor kit. I can probably buy this from Mauser for like $3 plus shipping, plus all the hassle of me trying to find the right cap with the right pin spacing and size. And you know, screw this. I'll just thank you, Console 5. You're doing a good job and saving myself some time here. So we're ready to go, and we're going to recap this guy and hopefully get less noise on the video and boot all the time. And again, this is our noisy power supply output here, and I've turned on the statistics on the scope here to show just how noisy. So the yellow is the 5-volt line and purple is the 12-volt line, and we can see that maybe we put the same scale here for the same scale for nope. We're gonna bring the 12-volt line back up so we can see it. Right, so they are at the same scale right now. So the 12 volt line is less noisy than the 5 volt line. And you know what? This is probably okay as far as noise go for 12 volt line, but for the 5 volt line, that is a lot of noise. And that is what's going to power the CPU, the RAM, everything. And you just this is just asking for problems here. So hopefully the caps smooth the situation. That's what caps are for. They're designed to filter AC, and we're going to see if we get an improvement. Science! A/B testing demonstrates that your fix actually fixed what you thought it was going to fix. Don't just shotgun this. All right, so we got the power supply out of that thing, and we're about to, before we recap it, I'd like to actually take a look at a few of those capacitors and do some testing, see if there is anything obviously wrong. Obviously nothing's bulging here, and nothing's leaking, but we do know that this power supply is, hang on a second, this power supply is definitely noisy, so the filtering is marginal. So let's take a look. Underneath this PCB, we're going to have to remove the this plate here. All right, so we got the board, the plate off. This is the bottom of the power supply, and we got our little handy dandy LCR meter over here. There are many like it, but this one is mine. This is actually a very affordable 20,000 count LCR meter. It's very nice. It's very accurate, at least as far as I can tell. And the way I like to set it up to test capacitor in circuit, that is, especially with this little guy right here, the little probe, you need to not put it in automatic. You need to select capacitor here, not parallel mode, but serial. And once you're in this mode here, not auto, this gives you the D factor for the device under test. I prefer to have the ESR value, which is the series resistance of the capacitor. I'm just not used to the D number as opposed to the ESR. I know the higher this ESR is, the worse the capacitor is generally, depending again on the capacitance. But this is how I like to set up this meter to test capacitor in circuit. So without further ado, we shall do that right now, and we'll start with the big guy. Let's start with the big guy, which is, let's see, this guy right here. Well, you know what we should do? We should probably attempt to discharge these. Yes. Always discharge big capacitors. You would be surprised how much juice they hold. And of course, if a capacitor that is not discharged into your very expensive equipment, your very expensive equipment will therefore be useless. So, and die. So discharge capacitors, it's always a good idea. So we go, and we got 189 microfarads at 0.1 ohm ESR. So this is a good cap. The spec on this is 220. It's a little low, but it's still within spec. Again, this is supposed to be a 20% spec on this, so plus or minus 20% on the capacitance is okay. And so this is essentially what I do when I try to troubleshoot something obvious. We're doing this in series, so this is, of course, in circuit, so this is, of course, not as reliable as taking the capacitor off the board and testing it that way, but it will show you obvious problems, and I think this power supply probably has an obvious bad one in here, and we should be able to detect which one it is with this, or maybe they're all fine, and you know, then it's pointless to actually recap this, or maybe it is necessary to recap this because they're marginal and they test okay. What I've found is these LCR meters, no matter how good they are, they will not. They will do a good job at finding obvious problems, but marginal capacitors might test okay. Even if you look at both the capacitance and the ESR, the series resistance, a marginal capacitor, even leaky cap, I've found actually test okay sometimes with somewhat low ESR. So yeah, just it's kind of a clusterfuck. But this is still something I like to do, just because I like to experiment with things and I find it interesting. So without further ado, let's do some testing. Tested all the caps, and guess what? They are all in spec and working, except this little guy right here, which is a 1 microfarad capacitor that appears to be somewhere in the 5-volt regulation circuit, but I highly doubt that's causing any problems. And so it tests actually on spec for the capacitance, but it tests very high on ESR. So we are at, there we go. We are well, not even now, it tests fine. Another point to note when you are using an LCR meter is to be aware of the frequency of the tests. Right now I am testing this capacitor at 120 Hertz, and the reason for that is because this being a power supply, the AC currents it's dealing with are AC. They're not DC, and they are at a very specific frequency, which is 60 Hertz. And so depending on the circuit, you can approximate what it is that you are testing and try to simulate as close as possible to what the circuit's getting. So this LCR meter will test, will have a signal coming out of the probes of 100 kilohertz to sort of excite the capacitor. And so for this power supply, I set it to 120 Hertz to sort of simulate line voltage and the conditions in which these capacitors are being used. In this case, 120 Hertz. This may not be true for all the capacitors. I'm guessing that this transistor here runs at a high pulse width modulation, probably a couple dozens of kilohertz. So it's possible that this one and this one are really 10 kilohertz or more AC signals, and possibly the bad one here, the bad 1 microfarad, which is back there, could be also a high frequency capacitor. But regardless, almost if you do end up using an LCR meter to test your capacitors and circuits, try to adapt the frequency of the test signal to what the circuit actually gets. So like this guy, for instance, is important to test it at 60 Hertz because that's the main filter capacitor. Haha. Also, a lot of LCR meters are not able to test very large capacitors unless their frequency is very low. So there's that too that plays a role. But we're not here about teaching about LCR meters. It's probably beyond the scope, but just a note, how to test circuits. So yeah, look at that. This power supply, as far as I can tell, is a-okay, but it's noisy as, you know, it's very noisy. So I don't know. We'll still recap it for science. All right, and we are back, fully recapped with the new Console 5 capacitors. We shall see now direct comparison. Is this having an impact on the ripple voltage that we were seeing earlier? So I have the oscilloscope here set up exactly the same way with the same probes. Believe it's same test points or similar. And we shall see if, despite the fact that these are the old caps, they tested just fine on my LCR meter. and in circuit, and actually did out of circuit since they're out off camera, and they test just fine. Good inspect, no problem. High quality caps too. This guy is these are Nippon Chemicon caps. You can see the logo right here. These are good Japanese caps. They're excellent. These over here I'm not so familiar with. Marcon. They're probably good. This is a Japanese made power supply. This is the same brand. This is 105 degrees. I'll tend to believe these ratings from Japanese made power supplies from the 80s. This is probably accurate. Another one of those 105 degree cap. So high quality cap overall. Nippon Chemicon here, these 4 brown ones. And then the rest is probably high quality as well. But the high quality console 5 caps, which are either Nichikon's or Panasonic, are they actually better, and will they improve the ripple noise? We shall find out right now. So turn it on. We have power, and wow, look at that. That is an absolutely clear improvement here. I'm astonished. We are down to 140 millivolts on the 5-volt line. Boosted a bit the voltage actually. We're a little higher than we were before. And just about 100 millivolts peak to peak on the 12-volt line, which has also increased. So we may need to tune that down. Just a smidge. And for that, we need to go here and come back here, and we're just gonna do 5 volts. This is right about where it needs to be under load. Just gonna give it just a smidge more. The 12-volt line is a 13-volt, but that's fine. This is still within an acceptable range. But yeah, no, this recapping did improve the situation significantly on the ripple noise here. So we should see probably improved stability of the computer, despite the fact, again, that these tested just fine. They tested ESR everything. They are in spec. So yeah, recapping. Who'd have thunk it? It actually improves things. Well, at least for ripple voltage. Huh.
So there you have it. As you can see, oscilloscopes are pretty useful tools, and in this instance, Kraz was able to see the variation in the voltage in the power supply, which led him to replace the capacitors on the power supply, and that ended up fixing the variation in the voltage, and therefore fixing the boot issues. So problem solved. Great job. So that's it for today. Remember, retro toilet, you flush it, we fix it. We turn your retro crap into retro gold. Don't forget to like and subscribe. Thanks a lot.
All right, you know what? This was dumb. Dump it. Trash it. This was garbage.